Imagine a world where every question sparks an adventure, where the tiniest curiosity can unlock the secrets of the universe, and where science is not just a subject, but a way of thinking, feeling, and experiencing life. Today we are about to explore the future of scientific discovery in a way you've never seen before. A journey that blends mind-bending experiments, real-world insights, and ideas that challenge everything you thought you knew. This is not just about learning facts. It's about awakening curiosity, questioning assumptions, and seeing the world through a lens of wonder and possibility. Stay with me, because what we uncover together will not only change how you understand science, but how you see yourself, your choices, and the endless potential of human thought. By the end of this video, you won't just have watched science. You will have experienced it, felt it, and been inspired to think bigger than ever before. The evolution of science communication in the digital age has transformed how knowledge is created, shared, and understood by society. In the past, scientific ideas were mainly confined to classrooms, textbooks, and academic journals, reaching only a limited audience. Today, digital platforms have removed those barriers, allowing complex scientific concepts to reach millions of people instantly across the globe. This shift has changed science from a formal, distant subject into an everyday conversation that anyone can participate in. Digital media has introduced new storytelling methods that combine visuals, experiments, animations, and real-world examples to explain ideas that once seemed inaccessible. Instead of simply presenting facts, modern science communication focuses on the process of thinking, questioning, and testing ideas. This approach helps audiences understand not just what is true, but why it is true, encouraging deeper engagement and critical thinking. The interactive nature of digital platforms has also reshaped the relationship between scientists and the public. Audiences can ask questions, challenge explanations, and share perspectives in real time, creating a two-way dialogue rather than a one-sided lecture. This interaction builds trust and makes science feel more human and relatable. However, the digital age also brings challenges, especially the rapid spread of misinformation. As a result, science communicators must balance accessibility with accuracy, ensuring that clarity does not oversimplify truth. The evolution of science communication now carries a responsibility to guide curiosity responsibly, helping people navigate information with skepticism, evidence, and reason. Curiosity has always been at the core of scientific progress, but in the modern world it plays an even more powerful role in shaping the future of discovery. Curiosity is the force that pushes individuals to question what they see, doubt what they are told, and search for explanations beyond surface-level answers. Without curiosity, science becomes static, repeating known facts instead of exploring new possibilities. It is curiosity that turns simple observations into meaningful investigations and ordinary questions into breakthroughs that redefine understanding. In the future of scientific discovery, curiosity will not be limited to professional scientists working in laboratories. Digital access to information has empowered students, creators, and independent thinkers to explore complex ideas on their own. This widespread curiosity creates a global network of minds experimenting, analyzing data, and challenging existing theories. When curiosity is encouraged, it leads to innovation because people are willing to test ideas that may initially seem strange or impossible. Curiosity also plays a crucial role in connecting different fields of knowledge. Many future discoveries will emerge at the intersection of disciplines, where physics meets biology, technology meets psychology, and data science meets human behavior. A curious mindset allows thinkers to cross these boundaries freely, asking questions that do not fit neatly into one category. Most importantly, curiosity fuels resilience in the face of failure. Scientific progress often involves wrong assumptions and unsuccessful experiments. A curious mind views failure not as an endpoint, but as information that guides the next question. This continuous cycle of questioning and learning is what will drive future discoveries forward, blending physics, psychology, and real-world experiments creates a deeper and more meaningful way to understand how the universe and the human mind interact. Physics explains the fundamental laws that govern matter, energy, and motion, while psychology explores perception, belief, and decision-making. When these fields are combined through real-world experiments, science becomes more than abstract theory. It becomes a reflection of everyday human experience. This approach reveals not only how the world works, but how people interpret and respond to it. Real-world experiments serve as a bridge between equations and intuition. Many physical principles appear simple on paper, but behave in unexpected ways when tested in practical situations. Human perception often conflicts with physical reality, leading to incorrect assumptions about motion, probability, or cause and effect. By incorporating psychological insights, experiments can demonstrate why the brain makes these mistakes and how scientific thinking corrects them. This blend also makes complex ideas accessible to wider audiences. When people see experiments performed in familiar environments, they are more likely to engage emotionally and intellectually. Understanding increases when abstract concepts are tied to human behavior, curiosity, and surprise. Viewers begin to recognize that science is not distant or detached, but embedded in their daily lives. Furthermore, combining these disciplines encourages critical thinking. It teaches audiences to question not only the external world, but their own reasoning processes. Recognizing cognitive biases alongside physical laws helps people understand the limits of intuition and the importance of evidence. This integrated approach transforms learning into an active process, where observation, questioning, and reflection work together to deepen understanding. Fighting misinformation through evidence-based storytelling has become one of the most important challenges in modern science communication. In the digital age, false or misleading information spreads faster than ever, often because it appeals to emotions, fear, or existing beliefs rather than facts. Simply presenting correct data is no longer enough. To counter misinformation effectively, scientific truth must be communicated in a way that is clear, engaging, and grounded in strong evidence, while still connecting with the audience on a human level. Evidence-based storytelling combines rigorous facts with narrative structure. Instead of overwhelming people with raw statistics or complex explanations, it presents information through real examples, experiments, and logical progression. This method allows audiences to follow the reasoning step by step, making it harder for false claims to take hold. When people understand how evidence is gathered and tested, they become less vulnerable to manipulation and more confident in evaluating information for themselves. Storytelling also builds trust, which is essential in combating misinformation. When communicators openly show uncertainty, acknowledge limitations, and correct mistakes, it demonstrates intellectual honesty. This transparency strengthens credibility and helps audiences distinguish between genuine inquiry and deceptive certainty. Trust grows when viewers feel they are part of the discovery process rather than passive recipients of information. Most importantly, evidence-based storytelling empowers critical thinking. It teaches people to ask questions, seek sources, and value proof over opinion. By making the scientific method visible and relatable, this approach transforms audiences from consumers of information into informed thinkers capable of resisting misinformation on their own. Making complex ideas emotionally engaging and human is essential for meaningful science communication in the modern world. Complex concepts often fail to connect with audiences not because they are unimportant, but because they feel distant, abstract, or intimidating. When ideas are presented only through formulas and technical language, they can create a barrier that discourages curiosity. By adding a human and emotional dimension, these ideas become relatable and easier to understand. Emotion plays a powerful role in how people learn and remember information. When a concept is linked to surprise, wonder, confusion, or even doubt, it leaves a lasting impression. Showing the emotional journey behind discovery, moments of failure, excitement, and realization, helps audiences see science as a human process rather than a collection of cold facts. This approach allows people to connect with the idea on a personal level, not just an intellectual one. Human-centered explanations also highlight why complex ideas matter in everyday life. When audiences understand how abstract principles influence real-world experiences, they become more invested in learning. Relating scientific concepts to common behaviors, decisions, and perceptions helps bridge the gap between theory and reality. It reminds people that science is not separate from humanity, but deeply intertwined with it. By making ideas emotionally engaging, science communication encourages empathy and curiosity instead of intimidation. It invites audiences to explore, question, and reflect without fear of being wrong. This human approach transforms complexity into fascination, motivating people to think deeper and remain engaged with ideas that once seemed unreachable. The responsibility of science creators in shaping young minds has grown significantly in the digital age where content is easily accessible and highly influential. Young audiences often encounter scientific ideas for the first time through online videos, social media, and digital platforms rather than traditional classrooms. This means science creators play a powerful role in forming how curiosity, skepticism, and understanding develop at an early stage. With this influence comes the responsibility to present information accurately, thoughtfully, and ethically. Science creators are not only educators, but also role models for how thinking should be approached. When they demonstrate questioning, testing ideas, and admitting uncertainty, they teach young minds that intelligence is not about having all the answers, but about being willing to learn. This mindset encourages humility and openness, helping students understand that changing one's view in light of evidence is a strength, not a weakness. The way science is presented also affects confidence and motivation. Clear, honest explanations can inspire young learners to explore further, while exaggerated claims or oversimplified conclusions can create confusion or false expectations. Responsible science communication respects the audience's ability to think critically, rather than manipulating attention through sensationalism. Most importantly, science creators help shape values alongside knowledge. By emphasizing evidence, reasoning, and ethical responsibility, they influence how young minds interact with information beyond science. This guidance equips future generations with the tools to navigate a complex world, encouraging curiosity, balanced with critical thinking and respect for truth. As we look toward the future, the true power of science communication lies not in delivering perfect answers, but in nurturing fearless curiosity and honest thinking. The Future of Veritasium represents a shift toward deeper questioning, human-centered exploration, and evidence-driven storytelling that challenges assumptions rather than comforting them. By blending disciplines, embracing uncertainty, and making complex ideas emotionally relatable, science becomes more than information. It becomes a way of seeing the world. In an era where misinformation competes for attention, this approach builds trust, critical thinking, and intellectual courage. Ultimately, the real success of such a future is measured not by views or algorithms, but by the minds it shapes and the questions it inspires in generations to come.